Hi everyone and welcome back. So in this particular video we are going to talk about the need of a workflow engine in a typical event driven architecture. Okay, so what we are going to do is we are going to take a look on the order fulfillment process, like any e-commerce solution you see, right? They are doing nothing but order processing. They are taking the orders, shipping it, notifying the users, and all these processes are involved, right? So, and all these solutions are built around microservices. Some are microservices with the event driven architecture, or maybe some different set of architecture, right? So we have like let's call it, these are 4 different services we have for the order fulfillment. One is a payment, one is a checkout, one is the order processing, any kind of services. Let's say it's a shipment. Okay, another service is inventory, and here we have a checkout and the payment. Let's say I have these set of services and I'm writing an order fulfillment application, and maybe this is already existing applications, and I wanted to use the concept of event driven architecture. Okay, I mean, in the microservice world you will see these terms, event, commands, and all these things, right? And I am just enhancing my architecture by using the event driven architecture. Okay, so how we are going to choreograph all these communication between different microservices? What we choose is we wanted to use the decoupled architecture totally. Okay, once the order will come, so let's say there is an order and that is coming from the end user. Okay, and that is going to initiate the whole process chain, because an order is coming, it will go, I mean, you will pay the item, fetch the item, and then end user will ship the item to you, right? So it is like a single point of invocation, and then everything is being done through the events. Order is received, order is fetched, inventory has checked, right? Order has been shipped, order has been received. All these different kind of events we have, right? So let's see how we are going to design this. I have these sort of microservices. What I did is I just put a, you can call it as a event queue. Okay, let me rotate this. Yeah, so let's say it can be SQS queue or RabbitMQ or Kafka, anything. Okay, so whenever anything is happening, you are just emitting the event and sending this event to the event bus. Okay, this is you are using, and there will be a subscriber who is listening for this particular event, and they will act on to this particular event. So this is nothing but you are letting the world know that something has happened, right? And the world will act on to that. Let's say this is a SQS, or let's say Kafka. Okay, you are just emitting the event and you are just letting the everyone know, okay, this event has arrived, now process it. There will be a subscriber which will listening to this. So it's kind of a decoupled architecture we have invented, and it is working perfectly fine. We are able to process the order. But what is the bigger picture we are missing here? The bigger picture is we are not able to track the, or we are not able to see the high level view. What is actually happening in the system? How many orders has been processed? If something is stuck, we will not be able to track it in which particular service that has become a problem, right? Because it's event driven, everything is a decoupled. Order service doesn't know shipment, shipment service doesn't know payments, and there is no centralized tracking of the state of the orders, right? So in this particular set of services, you are doing just creating the events, and this event is being posted. There is a subscriber listening to the event, maybe emitting the another event. So it's like this: you do the checkout, the goods shipped event will be created. It will call a, there will be a microservice which will be listening to that event. Then it will another emit the event like goods fetched, payment received. So it's all about the events we are talking here, right? So the danger is that you lose the sight of the larger scale flow. In this example, like order fulfillment, it becomes incredibly hard to understand the flow, change it or operate it. Even like answering the questions like what is happening in the system, how many orders are overdue, and we are not able to intervene to this whole system. We don't even know what is happening in this overall process, right? So what we do is, let's say we introduce the workflow engine in this particular set of architecture. Workflow engine, and that engine will do nothing but will listen to the events which are coming on the Kafka. Okay, so this workflow engine, if you are including like Camunda or something, then it will have its own state or something. You will be writing the workflow process, and here you will actually track each and every item. What you did is you are just listening to the events which are coming to this Kafka, and you are actually progressing this workflow. Okay, so order received, order placed, order processed, item fetched, and item delivered. Right, so here you will do, let's say, payment received. Okay, then you will see order completed or something like this. There is a whole flow, and finally you are doing order completed. Right, so these are the events, message events, I will call it in the Camunda language. These are the message events, and you are actually doing nothing but workflow engine is playing with this. Workflow engine is giving you the status of how many for how many orders we received the payment, how many goods fetched, how many has been shipped, how many has been delivered, right? So it's like you put a watcher, it is keep looking for the events which are happening, right? So this is about tracking. Now this workflow process, this is nothing but a business process we are writing based on our events from the microservices. Order received, then you are doing a lot of things, and finally order completed. So it can be a whole big span of events which are happening in the system, right? You might be also doing a lot of things in the order fulfillment, like send order delay message if the order is not processed or in 14 days or something like that. So there are a lot of complexity involved in this, and we can manage all these kind of communications and different set of events. We can track and manage both these things with the help of this workflow engine. It can be a Camunda, ZB, and maybe other solutions which are available on this planet. Okay, so this is just a simple example of workflow engine. Now we will talk about in what all different way you can actually embed this workflow engine into your microservices. You can just put this workflow engine independent to individual microservices. You can put this workflow engine. So this is the first example where we have included this. I mean, there is asynchronous event-driven communication happening. You put the workflow engine, you can track everything. Another thing is there is a request and reply services talking to each other. These are the REST microservices. You can put workflow engine to each and every service to track what is happening in the overall system. In that case, they will track the state of individual microservice. Or you can use this workflow engine as a centralized you can see centralized processing unit, and you connect all your microservices to this. So there are 3 different type of alternative architecture we can adopt that we will talk in the next video.